Good morning, dear students. In the last video in wave optics, we have studied how to find out the path difference and what is the light source and where we are taking the point and what is the path difference. And because of that, we can find it out whether it is constructive interference or destructive interference, everything. Okay, that is what we have discussed in the last video. And now we are going to study about the fringe pattern. Fringe pattern means dark and bright bands which is created on the screen, right? When the light source is coherent, two slits which is opening as a whole, and in that interference will happening. Constructing interference will create bright bands and destructive interference will create dark bands. That is what we have already discussed. And the distance between the fringes is called fringe pattern. The pattern is bright and dark pattern that we capture. That is fringe pattern. Okay. So what is fringe pattern? The alternate dark and red bands, that is white bands or red bands, dark and red bands, which are obtained on the screen are known as fringe pattern. And the alternate dark and the bright bands are known as fringes. There is alternate dark or bright bands known as fringes. Okay, in the diagram it is given in red, that is why it is showing that red bands. Okay, so alternate dark or bright bands which is obtained on the screen by the coherent sources, we call it as fringe pattern. Okay, next one, we are going to see bright bands. Bright bands, how it is created. So bright bands are formed as a result of constructive interference and their positions of maximum intensity. Intensity, if it is maximum, means if two crust and trough, if it is overlapping, that is constructive overlapping that we have studied. No. Similarly here, if the overlapping is constructive, more intensity it will create. So where the intensity is maximum, there bright bands will be created. Okay, and if the intensity is less, dark bands will be created. And the conditions for maximum intensity, to get the maximum intensity, the path difference should be the integral multiple of lambda that we have already studied for maximum intensity. So here the path difference is equal to integral multiple of lambda. That is what the condition for the maximum intensity to get a bright band. And we, in the last video, we have studied what is path difference and we found out the value for the path difference. Okay. What is the path difference value that we have found it for in the last video? It is x small d by capital D is the path difference that we have found it out. Just check the last video once again and you can recall it. How to find out the path difference for x small d divided by capital D. So we are substituting the value of path difference x small d divided by capital D is equal to n lambda, okay, using the previous video. So xn is equal to, you can see here, I have written it, I have given the same statement in the handwritten form. The condition for constructive interference is path difference should be integral multiple of n lambda. Path difference is xd by capital D is equal to n lambda. So what will happen? We want to find it out the position of the bright band, whether it is how many number of, what is the number of bright bands that we can consider, we can find it out over here. And the bright bands, center bright band, second bright band, fourth bright band, like this, number of bands will be there. So in this, nth number of bright band that we want to find it out means what will happen? This capital D will go top and this small d come as a denominator. So n lambda capital D, n lambda into this capital D go here and the small d come here. So xn is equal to n lambda d by small d. This is given for constructive inference, that is bright bands, how it is created. So xn is the position of nth bright band. See, listen this carefully. In many numerics, by using this formula only, we should find it out what is the nth, fourth bright band and the sixth bright band, like this they'll give. Whether it is constructive bright band means we have to consider this as n lambda, and if it is dark band means n plus 1 by 2 lambda that we should consider. So go through this video clear. Okay, so n is equal to 0, then it will be central bright band. Okay, and if n has some value means there is nth number of there is this number of bright band that we can consider here. Next we are going to see about dark bands. Okay, this is a dark band when it comes to. So when it comes to dark bands, here dark bands are formed by destructive interference and they are positions of minimum intensity. The intensity will be minimum. Why it is minimum? Because dark bands are created when the destructive overlap is happening. Crust and trough, if it is overlapping, means there is no waves are created. Light interference will happen where it has minimum intensity. So the condition for destructive interference is equal to path difference is equal to n plus 1 by 2 lambda. This also we have studied in the last video. Okay, so do one thing, go through the last video once again, then you will find it out why we are saying that the path difference is equal to n plus 1 by 2 into lambda. Okay, so path difference, we know the value of path difference. We have found it out in the last video that it is x small d divided by d is the path difference is equal to n plus 1 by 2 into lambda. So the same thing I have explained in the handwritten form. You can see here, condition for destructive interference path difference is equal to n plus 1 by 2 into lambda. Path difference is equal to xd divided by capital D is equal to n plus 1 by 2 into lambda. So we want to know this is what is the number of this dark band. What is the number of this dark band? This is nth number. This is third dark band, fourth dark band, sixth dark band. Like this, we want to find out the numbers. So what we have to do, we have to keep the x in here. Xn is equal to n plus 1 by 2 into lambda. This capital D goes as a numerator. This small d comes as a denominator. Okay. So xn is equal to n plus 1 by 2 into lambda capital D divided by small t. So xn is the position of the nth dark band. Xn, we know that it is a position of the nth dark band. Okay, and we should know in center constructive interference, if it is happening, n will be 0. N is equal to 0 means it is the center bright band. The bright band is created in the center. Here dark band means nth dark band, that we can find it out by using this, and this will be helpful in numerics. Okay, just keep this formula in your mind, in your fingertip, that what is the formula for bright band, what is the formula for dark bands. Okay, next we are going to see the graphical representation of the fringe pattern. Fringe pattern means that we know that this is the fringe pattern, right? This is a bright fringe, this is dark band, bright band, or when alternative bright and dark bands are created, this is dark band. So fringe width is nothing but the distance between the two consecutive dark and bright bands. Okay, so here you can see that n lambda is equal, n is equal to 0 means it is center. In center, intensity is maximum. Intensity is maximum means, can you see the center? This line goes and straight away meets it the bright band over here. So intensity is maximum at the center, so that this is center bright band. Can you see this? Path difference is given over here in the arrow mark. Path difference, what is the path difference? That is n lambda, 1 lambda, 2 lambda, 3 lambda. That is n lambda. N is equal to 0, 1, 2, 3. Like this, it will increase, right? That is what we have seen as a path difference. So n is equal to 0, and n is equal to 1, n is equal to 2, n is equal to 3. Like this, it will vary. Okay, here also n is equal to 1, 2, 3. This is comes on the other side. So can you see here? This is lambda by 2. This is lambda. This is 1 lambda. This is 1 lambda. In between 1 point is coming means this is 1 lambda divided by 2. So this is considered as the dark bands. So n plus 1 by 2 that we are saying, no, how we are saying this is in this form. So what is this? This is 1 lambda, and this is half. In between it is captured. So it is 1 by 2 lambda. Okay, so the path difference should be lambda by 2 for the dark bands. So phase difference plus or minus pi. Okay, I maximum, that is intensity is maximum, is bright band. Okay, the central bright band path difference should be 0, phase difference also 0, so that it is considered as the central bright band. So this is the graphical representation of a fringe pattern. Okay, I hope you understand this. Next, we are going to see about the fringe width. What is meant by fringe width? We know the width of the fringe. Okay, so fringe width is the distance between the consecutive dark and bright fringes. You see the dark and bright fringes down, the picture is there, right? Dark and bright fringes that you can see over here. So fringe width is the distance between consecutive dark and the bright fringes. Okay, and how it is denoted? It is denoted by the letter beta. This you keep it in mind. How we will be denote the fringe width? It will be denoted by the letter beta. So in case of constructive interference, fringe width remains constant throughout. Throughout it is constant. Can you see this? This constructive interference means the value is considered as the same increasing value, continuous same value. The width will be same throughout the pattern which is captured over here. Okay, so it is also known as linear fringe width. There is two types of fringe width is there. One is linear fringe width and another one is angular fringe width. This is what we are going to discuss in the next slide. For example, this is linear fringe width means we should know that in case of constructive interference, we know what is constructive interference is. If the constructive interference fringe width remains constant, okay, throughout. So it is linear fringe width. Now we are going to see about the linear fringe width beta expression, mathematical expression for the linear fringe width beta. Okay, so can you see here mathematical expression for fringe width beta? So just from here, mathematical expression for fringe width beta, there is xn is equal to n lambda d by d. This is the fringe which is captured at the initial point. Second one, dark fringes, x is equal to n plus 1. That is second fringe, x plus n plus 1. N means nth one, and n plus 1 means next to fringe. That is what we can consider this as n plus 1 into lambda d by d. So I have written it in the handwritten form. Can you see here? The expression for linear fringe with beta, there is xn is equal to n lambda d by d. This is for the dark band also that we have already seen. X into n plus 1 is equal to n plus 1 into lambda d by d. Okay, so we want to find out the fringe width means it is the difference between these two, consecutive distance between the dark and bright fringes. Okay, so what is the difference? So beta is the fringe width. So fringe width is equal to x into n plus 1 minus this. The bright band means we can find it out the one fringe width value. So xn plus 1 minus xn is equal to this n plus 1. So here we are substituting the value over here, lambda d by d. So n plus 1 lambda d by d. X n plus 1 minus xn is equal to n plus 1 lambda d by d minus n lambda d by d. So this value minus this value. So this value we are writing it here, and this value we are writing it here. This lambda capital D by small d, we are multiplying this inside. So what will happen? N lambda capital D by small d. This is the first one. Second one, 1 into lambda capital D by d. This comes as the second one. And the third one is minus n lambda capital D by small d. Okay. So what will happen? N lambda capital D by small d, n lambda capital D by small d, this minus and plus will get cancelled. So what is the leftover? Lambda capital D by small d is the fringe width. So fringe width beta is equal to lambda capital D by small d. Okay, that is what the explanation which it is given over here. So now you will understand the fringe with beta, what are all the factors it depends on. The factors which depends on, which is showing over here, their fringe width is depends on wavelength of the light used. Lambda is the wavelength. What is the wavelength of the light that we are using? It depends upon that. Second one, the distance between the screen and the slit. D, we know that it is the slit. From slit, what is the distance? What is the distance the screen is kept? So that is considered as a capital T. So distance of screen from the slit. And small d is the distance between the two slits. Distance between the two slits means that sources that we can consider secondary sources, S1 and S2. So distance between S1 and S2 is considered as a small d. So this lambda, this capital T is the distance from the screen to the slit, and the small d is the distance between the slits. So these are all the three factors which determines the fringe with beta. I hope you understand. This is the linear fringe with mathematical expression. Okay, beta. Next one, we are going to see the angular fringe with theta. Okay, this is the angular fringe with theta, and we know that these are all the dark and bright bands which is created over here, and this is x and xn. This is xn bright band, and next bright band means xn plus 1. That is what we have already seen. This is xn. This is xn plus 1. The distance between these two is beta. and we consider one straight light which is going and constructing the central bright band, and this is the nth bright band which is making an angle theta. So this is considered as angular fringe width. So angular fringe width theta is equal to beta by d. That is, I have given it in this form. Can you see here? This is the central bright band which is showing over here, and this is the second bright band. Distance between these two is beta. So theta is equal to opposite by adjacent. What is theta? Theta is equal to out is opposite beta divided by the adjacent. Adjacent is capital T. So theta is equal to beta by capital T. So theta is equal to, we can write it as beta into 1 by d. That we can write. We know we have already found out the value for beta. What is what we have found out the value for beta? Beta is equal to lambda d capital D by small d. This is what we have found out. This beta value we are substituting it in the here instead of beta. So instead of beta, lambda capital D by small d that we are substituting it here into 1 by d. This capital D will get cancelled. Okay. So if it is getting cancelled means the value which comes out to be theta is equal to lambda by d. So this is the angular fringe width value. This is also very important when it comes to numeric. These are all the formulas which you can remember frequently, so that you can do the numerics very easily. Okay, so what is the conclusion that comes to for Young's double slit experiment? So if the light source or center, it goes and makes the center bright band, and if the light source are making an angle theta, this center bright band also will move consecutively. Okay, the center fringe moves when the sources moves. This is the center fringe where the light is straight, and if the light moving over here means this fringe also will start moving down. So this is the difference over here. The central fringes get shifted by theta if the source is shifted by theta. So if source S is shifted by some angle theta, there will be no change in fringe pattern. The central fringe will get shifted to the opposite direction. If the light source is shifted upwards, the fringe will shift downwards. So the intensity of fringes increases if point sources are replaced with slits. We know point sources, that is a small hole means that is considered as one source. Instead of point hole, we can use a small opening. Slit means more number of secondary wavefronts are created. If there is a slit instead of point source, more light waves will be able to pass through the slits. So as a result, stronger wavefronts and formed, which gives to the even greater intensity of fringes which we will get. Okay, this is what the conclusion we get it from Young's double slit experiment. Okay, and the rest of the thing we will see it in the next video. Thank you.